we will discuss about jet level profile machining. Jet level profile machining, you can use either 2D machining or 3D machining. Now I am going to explain first 3D profile, then after I will explain 2D machining. In this case, you can create model or import model already you drawn. Now I am importing model 3D profile. This 3D profile combines fillet radius top and also fillet radius bottom, and these surfaces are taper. We go to machine these areas. First we will go to applications, go to manufacturing, go to geometrical view. MCS mill means machine coordinate system mill. We go to put right hand, edit, specify MCS, you can specify this point. Okay. The clearance option is automatic plane and safe clearance distance is 10 mm. It is the meaning of that cutter diameter of tool will come 10 mm above the surface of the workpiece. Then second one we have to go for workpiece. Go to edit. Here we go to specific part. This is my part. And we go to specific blank. We are giving so many options: geometry, offset from part, bounding block, bounding cylinder. We have to select it bounding block. And in X, Y, Z direction, I am not giving any value as it is. This in my library, I am giving a lot of materials, workpiece materials. That code number 116 is having carbon steel and it has 100 to 150 hardness and it is free machining property. I am considering this is the workpiece material. For reference purpose, I am putting mild steel. So far we completed MCS mill and workpiece. Now we will go for create operations. Go to contour. Here you will see lot of options are available. This is jet level profile machining option. Go to program. Tool we will select it. Geometrical, go for workpiece. Method we can finish. That name you can give it by default jet level profile. Here part is there. We go to specific cut area. This is my cut area. Check it. Okay. Then I will select tool material. You can go for retrieve tool. Lot of options are available. Go to milling. Milling, you can go for end mill, non-indexable, indexable. Non-indexable, I can select it. There are so many sizes are available. 2 mm, 8 mm, 6 mm. I am considering end mill 50 mm. Here, the depth of cut is I am going to give 0.5 mm in every steps. Cut level you can check it. Depth is 50 mm and depth per cut is 0.5 mm. Then go to cutting parameters. We can check it. Stock material. We have not given any allowances. And connections. First option is we are going to use transfer method. Please note down first option I have taken use transfer method. Non-cutting moves. Engage. We can engage the cutter by using helical or ramp on shape or plunge. Better we can go for helical or ramp on shape. Retract after completion of machining, the tool will retract from the surface of the workpiece. The final one is feeds and speeds. Here we are taking workpiece material mild steel and tool material cutter is HSS. So the surface speed is 30 meter per minute. You have to calculate. Here 0.1636 feet per spindle speed is 191 RPM revolution per minute. Put it optimize feed rate. Now we have completed part, cut area, tool, depth of cut, cutting parameters, non-cutting moves, feeds and feeds. First option we are going to use transfer method. First option. Please note down. Now we will generate each and every time it will take 0.5 mm depth. It will take some times. First option we are use transfer method. Now we will explain what will happen if you are putting use transfer method. Okay. Now we will verify our toolpath. Click it, go to toolpath, verify, make it 3D dynamic, very slow. So in this case, you please change your orient view right hand side. Now it will be very clear how the tool will come, approach and departure, and how it will touch the workpiece and how it will cut by using first option, use transfer method. See, the tool is coming and approach the profile like this way. Now it is after completion of one cut, it will departure here, then it will go outside, then here it will take depth. Means each and every time it will use approach, doing machining and departure from the machining and lift the tool, then give depth of cut in outside. This is first option. Now I will make it little bit animation speed faster. Now you are knowing that this option what it will do, it will take depth of cut in outside of the material. Now first option is completed, use transfer method. Now after completion of this verification, second option we will go it. It will take some time. Okay. Method. Now we will go and do second option. Go to edit. I will not change anything. Only I will go parameters, click, then connections second, Here, second option, I am going to take it direct on part. This is second option. Remaining every parameters are same. I go to generate the work path. Now direct on part is going on. Second options. Remaining all parameters are same. Only I have changed in cutting parameters. I have changed second options, and we will check it how it is working. Now we will go for third options. Go to jet load profile. Go to edit. Go to cutting parameters. Then third one is ramp on part. Ramp is nothing but how the cutter will engage with the workpiece in particular angles. Normally 5 to 10 degrees you can put it so that it will reduce the load for the cutting tool. Then OK. Remaining all parameters are same. I have not changed anything. Parameter I have changed in ramp on part. Then we will go for generate. Ramp is the particular angle the cutting tool will come and connect with the workpiece. Now the program is generating. Take some time. Then save it. Go to toolbar. Make it 3D dynamics and make it very slow for initially. Then we will check it how the cutter is engaged. It is almost same on direct and part. The only difference is that the tool will come inclination 5 to 10 degree and it will contact the workpiece. Now we will make little bit faster. Now this is third option of jet level profile. OK, save it. Then we will go for fourth options. Each and every parameter save. I have change here only. Stagger Ramp on part. See, there will be not or there is no great difference between Stagger Ramp and part or ramp and part. It is slightly it is variation, and you can give the degree of 7 to 10 degree. I made it 7 degree. It is not required if you are putting 7 or 8 or 10, means the minimum angle, means up to 10 to 15 degree you can go. Then we will generate the workpiece. This is the fourth option for jet level profile. Here we are explaining that what are the options available for jet level profile, and we explain each and every method. Here we are explaining that what are the options available for jet level profile, and we explain each and every method. One is on transfer method, another one is direct on part, third one is ramp on part, fourth one is stacker ramp on part. You can use any options as you like, or as per our model, or as per your manufacturing process. Okay, make it, save it. We will go and verify. Initially we make it slow. How it is engaging, we will see. Then we will increase the animation speed. You can use any options as per your requirement of manufacturing or machining process. It will depend upon your model, or it will depend upon your part. Okay. Now we will save and close it.
Thank you for watching. Please like, share, and subscribe.